of inference. Okay, how to prove this rules of inference? Um, some formulas will be there, rules of inference formulas. Just to go through all the formulas once again. Okay, I don't want to go with the formulas. You can go and read the formulas and study the formulas. Okay, now we can start with the problem, how to solve the rules of inference problem. And all first problem, very simple problem. Let me start. Prove the following. Prove the following. Prove the following. Argument is valid. Valid. P condition not Q, comma R condition Q, comma R, which implies not P. Okay, fine. So this we have to start using all these premises, and finally we have to reach not P. Okay, fine. Serial number, statement, and reasons. Okay, so you can draw like this table, so easy to find the answer. So first you have to introduce the premises. Whenever you introduce the premises, you have to reason, that is rule P. Rule P stands for introducing a premises. Okay, so rule P. Second one, I can introduce all the premises. Okay, so that is going to be second one also. R condition Q, that is also rule P. Third one R. Okay, rule P. Now using this, okay, you have a formulas. Okay, there are a lot of formulas will be there, but some of them are important, very important formulas we very often use in our rules of inference. So I will go through that formulas, and then we can see how to solve this. Okay, the first few formulas, first I will go with the simplification. Okay, addition. Okay, addition formula is nothing but if you have P, okay, you can able to write P R Q. Okay, if you have Q, okay, you can able to write that is also P R Q. So that is what addition formula. Then simplification formula. If you have P and Q, you can able to write P. If you have P and Q, you can able to write Q. Okay, fine. Therefore you can write Q. Simplification. Modus ponens. Okay, so modus ponens. Okay, ponens, it's a mathematician name. Modus ponens, that can be written P and P condition Q. Okay, P and P condition Q is nothing but Q. Modus ponens. P and P condition Q is modus ponens. Then modus tollens. Modus tollens. What is modus tollens? Modus tollens is nothing but not Q and P condition Q is nothing but not P. Modus tollens. Okay. Then we use disjunctive syllogism. Disjunctive syllogism. Disjunctive syllogism, that's going to be PRQ. Okay, not P and not P. PRQ and not P is equal to Q. Okay. Then hypothetical syllogism. Hypothetical syllogism. Hypothetical syllogism, that is nothing but P condition Q. Okay, and Q condition R can be written P condition R. Okay, fine. Last one, conjunction. Okay, so that is going to be conjunction, that is P and Q, if you have P, Q, okay, we can able to write P and Q, P, Q, okay, P comma Q, or you can write P comma Q, P comma Q, then we can able to write P and Q, okay, so that is what conjunction, okay, so that is conjunction. So basically we use only this formulas, still we have more than this, okay, whenever we need we can use that formulas, okay. Now come to this, P not Q, or we have to prove it, it's going to be not P, R Q R. See, this two letters are same, is it right? This two are same. So R 1 and 2, there is a connective that is called the AND, okay. So this is nothing but R and R condition Q, okay. That means 3 and 4 you are getting this one, okay. So this is nothing but modus ponens, modus ponens, is it right? Modus ponens. Very often we will use this formula. P and P condition Q is equivalent to Q. So I can write straight away, this is equivalent to fourth one, equivalent to Q. Fourth one, it's equivalent to Q. Okay, fine. Modus ponens. Next, okay, you can take this and this. It's modus tollens. Modus tollens, if you forgot modus tollens, we can do one thing. Contrapositive and modus ponens is modus tollens. Okay, straight away you can write modus ponens, modus tollens, no problem. But if you forgot, okay, so then you can apply contrapositive and contrapositive modus ponens. It's going to be modus tollens. Okay, first one is going to be, so this is going to be contrapositive. Contrapositive. What is that contrapositive? That means P condition Q can be equivalent to not Q condition not P. This is what is contrapositive. P condition Q is equivalent to not Q condition not P. So this can be P condition not Q. So this will become not Q, that is not of not Q. So Q condition not P. Okay. So sixth one, so 4 and 5 modus ponens, okay, modus ponens, that is going to be not P. Okay, we got the answer. So this is what rules of inference we very often use and find the answer. Okay, I think it's okay. And now we go for some other problems, serious problems. Okay, this is very simple problem. Here we have three different methods. Okay, we have three different methods. One is called direct method. One is called direct method. Okay, sorry. Okay, three methods we have. One is direct CP rule, indirect method, indirect method, and the inconsistent method. Another one is nothing but it's called the inconsistent method. I think so. Inconsistent method. Inconsistent method. Inconsistent. Okay, inconsistent method. Okay, so there are three different methods will be there. Okay, one is the CP rule, indirect method, inconsistent method in rules of inference. CP rule, what you have to do, suppose you want to prove P condition Q. Okay, final answer should be, there are a lot of premises H1, H2 up to etc, some Hn you have. Okay, finally you have to prove P condition Q, means what you have to do, you have to take P as one of the premises. Okay, finally arrive Q, then you can able to write finally if you arrive Q by using the given premises. Okay, finally you arrive Q by using the given premises of this. Okay, here finally you arrived to Q now, then you can able to write P condition Q. Okay, so this is what CP rule. What C, You have to prove P condition Q by using this premises. What your rule says, first you have to assume this value P, and using this all premises finally obtained Q. Okay, if you obtain from P to Q, then you can able to write it. This is P condition Q by CP rule. Okay, this is called CP rule. Okay, fine. Next one, indirect method. Indirect method, what you have to do, you have to prove. Okay, final answer will also conclusion given to you. Conclusion is given to you. Okay, you have to take the conclusion, negation of the conclusion also one of the premises. Okay, you have to consider negation of the conclusion also one of the premises, and then you have to prove finally false. Assume. Okay, so for example I am taking a condition, indirect method. So let us consider finally you have to prove P condition not as some H1 H2, some premises is given to you, H5. Okay, some premises is given to you. Okay, you have to prove this one. Okay, so what you have to do, you have to take the contrary for this. Okay, what is the contrary? So not of P condition not S. Okay, you have to take the contrary for this, and finally you have to prove false, and add this also one of the premises, and finally if you prove false, then it is going to be indirect method. What do you have to do? See, the conclusion is this, and this all the set of premises. Use this, and you have to prove this by indirect method. Means what you have to do, you have to take negation for this and add all this, and include all this premises. Negation for this, and include this also one of the premises with this. Finally obtain false, then it's going to be indirect method. Okay, you have to finally obtain false, then it is called the indirect method. Okay, fine. So what we say, we need to assume the contrary for conclusion and add that also one of the premises, then prove to be a contradiction or a false. Okay, then it is going to be an indirect method. Okay, fine. Inconsistent. Okay, what is that? Inconsistent is nothing but finally you have to prove false. Okay, the final conclusion is going to be false. Okay, by using the given premises H1 H2 up etc, whatever it may be, H8. Okay, using all these premises, finally if you prove false, then it's going to be an inconsistent method. So we're going to see one problem in each of these types. Okay, first one, show that R condition S can be derived from the premises P condition Q condition S, comma, not R or P. Okay, and Q, not R or P and Q. Okay, so this is going to be serial number, statement, reason. Is it right? Okay, first one, include all the premises. See, we have to prove this R condition S can be derived from the premises, so we have to derive this one. Okay, fine. P condition Q condition S. Okay, rule P. Second one, not R or P, rule P. Third, Q, rule P. Fine. Now we need to prove R condition yes. So whenever you come across R condition yes, it's going to be a CP rule. Add this also CP rule. Okay, 4. Okay, R is also one of the premises. Okay, CP rule. Okay, it's going to be CP rule. Okay, and finally you have to prove yes. Okay, if finally if you prove yes now, then you can able to write R condition yes by CP rule. Okay, so by concept of CP rule. Okay, fine. So this how you can prove. This is all tautologically proved. Okay, so here not R and not, okay, R, see here, not P, okay, sorry, P R Q, not R. Okay, is it right? Okay, so you can apply the disjunctive syllogism. Okay, disjunctive syllogism for this and this. Okay, P R Q, okay, or not R. Okay, so then what will get it? This is equal to P only. Okay, by P disjunctive syllogism for 4 and 2. Okay, disjunctive syllogism, we get P. Okay, sixth one, this and this. Okay, that is 2 and 5. 2 and 5, modus ponens. Modus ponens will get Q condition yes. Correct? Modus ponens. Seventh one, for 3 and 6. 3 and 6. Modus ponens, MP, modus ponens, that is going to be yes. Okay, so we have reached. Okay, so that is going to be reached. So we have started with R and ending with yes. So eighth one, R condition yes by CP rule. This is all rule true. Rule T. Okay, rule T. Rule T. Tautologically it's true. Okay, rule T. Okay, so by CP rule we can write like this. This is also CP rule for indication. I say we are introducing the premises only, so rule P. This is CP rule. We got the answer. Okay, so that's it. Okay, so this is the way you have to prove. Okay, you may ask. Okay, fine. Then indirect method on problem we can see. Indirect method. Indirect method and contradiction. Okay, so both we can see. Indirect method, inconsistent and indirect method. So that is using indirect method. Using indirect method of proof, derive P condition not as from the premises P condition Q R, comma, Q condition not P, comma, S condition not R. So what you have to do this in logics, serial number, statement, reasons. So introduce all the premises. Before that, what we have to do? Indirect method. Okay, so we have to take the contrary for this P condition not S. So what is the contrary? Not of this is equivalent to not P or not S. So if you take this not inside the bracket, P or S, okay, this also you have to introduce one of the premises. So first one, okay, P condition Q or R, rule P. Second one, Q condition not P, rule P. Third one, S condition not R, rule P. This also you have to use P or S, rule P. Okay, so what can you do with this? Okay, so that is, sorry, P and S. P and S, because when De Morgan's law apply, not of not P, P, and this is going to be R will turn to and this is S. So similarly here also and. P and S. Okay, fine. Fifth one, simplification. Is it right? Simplification for 4. Rule T, simplification. Simplification. So that is going to be P. Okay. P or S. Okay, sixth one, yes. Fourth one, simplification. Fine. So P and this one. Okay. So seventh one, 5 and 1. Modus ponens, MP modus ponens, so 5 and 1, QRR. Okay, fine. Then yes, okay, so 8th one, 6 and 2, oh, 6 and 3, 6 and 3 modus ponens, that is not R. This 7 and 8 disjunctive syllogism. Okay, so that is going to be give Q. Okay, Q. And there is Q 10th one, 9 and 2 modus ponens. Okay, so you will get not P. Okay, fine. 11th one, P and not P. Okay, so that is 10 and 5 conjunction. This will got this 12th one, negation law. It's going to be false. Negation 11th one, negation law. It's going to be false. Okay, fine. So this is the indirect method. Okay, this is the indirect method. Fine. Now we go for one more problem in rules of inference. Inconsistent method. Okay, so that is going to be prove that the premises A condition, B condition C, comma, D condition B and not C, and A and D are inconsistent. Okay, fine. So this is all inconsistent. We have to prove finally false. Okay, fine. So serial number, statement, reason. So that is going to be, first we have to introduce all this. A condition, B condition C, rule P. Second one, D condition, B and not C, rule P. Third, A and D, rule P. See here, this, and only we have to know simplification. Okay, and when comes you can split this simplification for a third one simplification by rule T. Okay, simplification. Okay, fifth one also D. Okay, by third simplification. So a sixth one 4 and 1 MP modus ponens. So you will get B condition, no C, B condition C. 2, 5 and 6 MP modus ponens. 5 and 2 modus ponens. So that is going to be 7th one. B and not C. Okay. Then 8th simplification. B, 9th one, not C. Okay. 7th simplification. 7th simplification. Okay. 10th one, what you will get? Not C, B. This what you will get. Now you have to get C. Okay. So 8th and 6th MP modus ponens, you will get C.